All right, in this video, we're going to talk about rescaling's composition in graphs. So we're given a function f of x, and we'd like to see what's the effect of rescaling either the dependent variable or independent variable. Let's think about rescaling the dependent variable first. For example, we could have this function f of x, and then we decide to multiply all the values by 2, so 2 times f of x. That's a composition. It's a composition with the rescaling by 2. So what is the graph of this? Well, we just rescale. We rescale all the values. So if f of x is 0, like here, nothing happens because 2 times 0 is 0. If f of x is 0 here, that's where, okay, then we get 2 times 0 is 0, so nothing happens. But up here, the value of f of x is 3. So in that case, 2 times 3 becomes 6. So let's see geometrically what happens to the graph. It just gets rescaled up, up, until we get to 6. Is that 6? Somewhere around there. Okay, so notice nothing happened at the 0, but we stretch all the way up to 6. So the result of this is stretch vertically, stretch. Let's see if we can spell stretch. Stretch vertically by a factor of 2. Okay, keeping the zeros fixed. Okay, let's move on to a different example. In this example, I want to consider something like this, where I have f of x, and I want to multiply each value by a number less than 1, say 1/2. Okay, well, this is going to take the y values and make them 1/2 what they used to be. So a value of, say, f of x is 4 becomes f of x equals 2. 0, again, if I have a value of f of x is 0, it still stays 0. So the effect of this multiplication by 1/2 shrinks the graph vertically, because the number here, 1/2, is less than 1. You could say it shrinks by a factor of 2. Okay, so it's shrinking. Okay, that's all well and good, but when you start talking about changing the x-coordinate, things are a little trickier. Suppose we now rescale the x variable, the independent variable, instead. Well, multiplying that x variable by 2 actually shrinks the graph by a factor of 2. So we're going to shrink in the horizontal direction. Because it's the x variable we're changing, this shrinking is going to be horizontal. And so this value of x equals 6 will become 3. So there's our new graph. This is the graph of f of, f of 2x. Okay, we shrink in the horizontal direction by a factor of 2. So shrink, not shrink. Okay, well then how do we get stretching in the horizontal direction? Well, you could take something like this, f of x, and then you could say f of x changes to f of 1/3 x, or you can think of this equivalently as f of x over 3. So dividing by 3 or multiplying by 1/3, what this does to the graph in the horizontal direction is it'll stretch it by a factor of 3. So this will move all the way out to 9 or something. So that's going to be by a factor of 3. Stretching horizontally by a factor of 3. Okay. Okay. What else can we do with rescalings? Well, there's one kind of rescaling which is a little different. It's actually reflection. Instead of having f of x, we could talk about minus f of x. Okay, so I actually composed with the function which returns minus x if I plug in x. So if the graph of f of x is this, what's the graph of minus f of x? Well, if I have some number that's a positive f value, then it's going to become negative when I put the negative sign there. So the graph reflects around the x-axis. So this is the graph of minus f of x. Everything reflects about this axis. On the other hand, I could also look, instead of putting a minus sign on the dependent variable, I could put it on the independent variable x. So I could look at f of minus x. It's a little bit different. What happens here? Well, every positive x value then becomes negative. So that means that I reflect about the y-axis. So the new graph, after making this reflection, looks like this. So this is the graph of f of minus x if this is the graph of f of x. Okay, let's move on to a more complicated example, something you might see in your text. So here I have a function which is 1 minus 2 times f of 2x. I'm given that this is the graph of f of x. I want to find the graph of this new function. What do I do? Well, always when working with compositions, you work from the inside out. So the first thing we're going to do is work on the inside of the function f. That's the 2x that's here. So instead of we want to figure out what is the graph of this part, f of 2x. Well, remember, if you multiply the x by 2, then that shrinks horizontally the graph by a factor of 2. So I'm going to take this graph and shrink in half. Now it's shrunk in half. And this new graph is the graph of f of 2x. Okay, the next thing I work on is the 2, because that's the next thing I do to this function, is 2 times that. 2 times that means that I stretch by a factor of 2 in the vertical direction. So I go up by a factor of 2. So the new function is going to be 2 times f of 2x. Next thing is I have a minus sign. What does the minus sign do? It reflects across the x-axis. So I get something on the other side, something like this. So this is reflection of that graph. And so this is now this graph is minus 2f of 2x. The last thing I do is I add 1. What does adding 1 do? It shifts upwards by a factor of 1. Okay, so this is the graph of minus f of 2x plus 1.